Okay, should be live again. Let's give it a sec for things to kick into gear. Yep, looking good. I don't know why I just made a tweet and it got like 3 likes so far, which is rare for stream tweets. I don't know if notifications are slow or what. But yeah, welcome back. Last time was frustrating with the with Apple deciding to overcomplicate the new touchpad and the keyboard protocol, because of course they would. But thankfully, I think I mostly worked out how that works. Last time, there's still a pile of commands that I don't know what they do, but the remaining the remaining stuff is, at least there's no. I didn't notice any particularly large magical blobs or anything, so I'm hopefully not wrong this time that it shouldn't actually take much more to make it work. Well, we know the keyboard can be made to work easily, so that's easy. It was just the trackpad in it that Joey says, I'm in the office today watching on my phone, so please use a huge font. I will try, but no promises, sorry. Yeah, the trackpad ended up being a bit more ridiculous than one might expect. But yeah, by the way, last night I was working on the Asahi installer a bit. So now it actually extracts these firmwares that we didn't extract previously and stores them in our fallback. Sort of, this isn't ready for Linux yet, but we put it in a tarball so that we can reprocess it later from a Linux package and like post facto add support for drivers. So right now, unfortunately, that means that this is needed for Touchbar support, it seems. And so M1 MacBook Pro owners that installed Asahi to date will need to use an as yet non-existent installer option from macOS to get Touchbar support when that is developed, because it's missing firmware that Linux can't get right now. Like I tried to avoid that happening by having this fallback thing, and I didn't realize that it was extra firmwares from different places that I needed to include. So the installer now includes that. It's not released yet, but obviously when M2 support is released, we need that for the touchpad and the keyboard to work, and we need an actual extractor for those, which I will write. Well, it's what I did last time, right? It's the it's a plist to binary thing converter and just a bit of logic around that. But unfortunately, that does mean that, you know, I've so far I've been telling people to get support for new features. You just do a Pac-Man upgrade. This is going to be so far the one time that people who installed to date will need to do something beyond the Pac-Man upgrade to get touchbar support. But that's not a huge deal. It's just, you know, unfortunate that not everything went as planned. And I mean, basically I'm going to make an installer option that is like a repair option that just kind of reinstalls all the bootloader stuff, so people can use that in general to fix problems and also for this firmware thing. But yeah, we're doing it pretty good, I think, so far as things go. So let's switch to the screen and let me just check a few things first. I think I'm fine here. Yep, okay, yep, we can go, there we go. Make sure I get the IRC too. So yes, so yeah, I have some preliminary extraction. Basically what the installer thing does right now, it is pushed to the repo, it's not released yet, is that it extracts all firmwares that are part of the same group of per OS firmwares, like the GPU firmware and stuff, but only the ones that are not loaded by iBoot, which is something we can actually get from the metadata that Apple has. Funny enough, that includes the ANE 1, 2, and 3 firmwares. I don't know if Apple ever enabled any extra ANEs. Maybe those are not loaded by iBoot just because they're disabled so far. So that might just be extra bloat. But just in case, I'm going to leave them there. I'm not going to add an exception for that because we, you know, hypothetically could need them at some point. But yeah, right now, basically, that includes the Touchbar firmware, also the trackpad firmware for M1, which is actually a firmware update, so that actually gets flashed to the trackpad. So we don't do that. We probably won't ever need to actually do that because you will be running that will have been done by macOS anyway. But it does get included in the package. But yes, importantly, it includes it's actually in a separate file, right? There's two firmware files on the M2. There's one for the Touchbar and the blob I found yesterday. Those are in one file, and it's like basically runtime multi-touch firmwares. And then there's another file for the one that gets flashed to the trackpad, which just as on the M1 we aren't going to need. So it's kind of interesting how like one firmware moved from inside that bundle to the other one, and the other one is strictly loaded at runtime. The other one is strictly flashed. But yeah, basically it's gonna work out. Oh yeah, and Sven, did he actually add the BT firmware to the installer? I didn't see that yet. I know we do have that in the fallback tarball. So once I release the once I still have to do this, but it's being on the list that I'm going to make a Linux package that just has the installer stuff as a Python module, and then on the post-install phase, it runs on that tarball that we prepared and re-extracts firmware, and that's how we're going to get the. Oh, he made a PR, cool. So that's good. So yeah, once this is, I just merged that PR, and then once this is done, that means that I just have to package it as a Linux package, and on post-install, it will install the missing Bluetooth firmware and do the updates. So for Bluetooth support, we can just Pac-Man upgrade when we get there, and that might also happen this weekend. If I, it's going to be in the, as usual, like sort of alpha, this might break state, but I would very much like to do a upgrade of the kernel and the installer and the OS images this weekend. And if I can say we have M2 support and Bluetooth and Mac Studio support, that would be great. So that's kind of it's actually been a while since I've been wanting to release Mac Studio support, but Bluetooth is kind of the cherry on top. So that's good. Yeah, someone says that the Linux driver works on more than one machine. Yeah, the good thing about Bluetooth is that it's actually very simple at the HCI layer. So there's not actually that much to go wrong. It's not like Wi-Fi. It's not like all bespoke things like DCP or the GPU. Like there's a limited set of things, and once they work properly, Bluetooth should mostly just magically work for the most part. So that means that once Sven started working on this, it's quite likely that we can that will go from no Bluetooth to basically working Bluetooth for everyone. In this short time. It's been a few weeks. So yeah, that's good news. So yeah, let's get back to this MTP stuff. So since I mostly understood how that works now, what I'm going to do is take all this tracer stuff that I wrote. Take all these data structures that I created. I guess those go in firmware now, so I'm going to move them somewhere else. mtp.py, they can go in here. And then I can just reuse them. And I'm going to make a little test in the MTP experiment just to prove that I can initialize the trackpad and try different commands, just to make sure that I have the init sequence right, basically, for everything. So I'm going to just make a very, very quick and dirty prototype of what the Linux driver is going to look like, and then basically just translate it to C. The good thing is that because this is Python, it's going to be very easy, actually. Python just makes doing things so much easier than than everything else, yeah. So I think this is right. Don't need proxy utils, just construct utils should do it for this. Yeah, I think I can live with that. Let's see if those are enough. So we have the Dockchannel. I guess I can have a class here to deal with everything else. So let's we're gonna need more than one class here, but let's call this MTP protocol. You gave it a Dockchannel, a U. And then really what we want to do is initialize self. The question is, how do we know that we've initialized everything? Because we get like initial notifications of different endpoints. But I guess there's no. I mean, Linux doesn't care because it can just like react to these things. Actually, let's just say wait init and self. This would be interface. We can use the interface names for this. And then we can just do like wait init keyboard, wait init multi-touch, and all the actual inits will happen in the background. But this way we can like sort of drive the loop. So self.interfaces. So it's iFaces. Let's say this one is by we have one by ID and one by name. We probably want both. Not in self.face by name or not self.iface by name. Let's just call that iFace. Actually, let's just do, yeah. Self.process. It was just work, actually, same as I do for the ASCs. Yeah, and just do it like that. And now let's actually do the work function. So I need yeah, I guess let's do read packet. So we need to get 8 bytes from the I can steal some of this from the tracer. And we can just assume that it's going to be clean. Self.dockchannel. What was M type? I forgot what that was. I'm not even printing that now. Was it just 0? I think it was. Oh no, it was always like command and response. It was always the 1. Yeah. It was this thing, right? 11 and 12. 11 for commands and 12 for replies, right? I think. And then we have size, counter. We're gonna ignore the counters. I don't know if the counters matter. They might. MTP, as in I assume multi-touch processor. I'm guessing. And then we actually need a class MTP. What do they call it actually? Com. Let's say an MTP interface. And then we do MTP com interface. And then we need something to process packets here. Self. This is going to have. Yeah, that's going to have to go through the parser. So now we can check for like notifications. If msg dot msg if it's an ACK, so for device control, we have, although some of these weren't quite right. Yeah, just say we get the message, it's going to get parsed it like that. Message tx message dot header dot flags equals 80. The other thing was like the interface or something like that, which I need to figure out how that works. But for now, we're gonna do it like this. Length equals say 0 for now there. Okay, so for the interface, for that, send self message. And so for this one, we actually would just do self.proto send self.iface iface probably just like that will work. So in read packet, we get the H&M type size counter div ID pad. So here for the interfaces, I can just say 0 and to become interface self 0, and in iface by name com. So that will be the first interface that we have implicitly at startup. Enter div ID pad. And then for the size, we had C. I think that includes everything except the checksum. Did it? Did it count that right? Yes, I did. I'm getting the feeling these messages are always multiples of 32 bits. But I'm not going to bother with checksums right now with verifying them. No, actually I am, you know what? So this is little endian. And then I think everything has to add up to FFFFF. So that should work. Something like that. Yeah, the checksum algorithm should just be a 32-bit sum. I didn't. I think I mentally calculated that a few times last time. I never actually wrote the code, but I'm pretty sure that's what it is. So work. Get a packet. So from this we can return. This is dev ID and packet. Actually, we can just do that. Yeah, we'll do it here. Let's process it like that. Well, Asahi Linux support the Touchbar eventually. Not there yet. Though probably not, like if whether it will support it in the sense that, applications will have support for like doing fancy things with it, that's pretty much up to other developers and stuff. But we'll make sure we can at least use it as like a function row and the basics. Like doing what macOS does with the touch bar requires a lot of development effort on the user space side that we don't have people for. So that very much depends on other folks that are interested wanting to add support for that. But yes, like at the very least, I'm going to eventually put together something so you can have function buttons and basic media keys and stuff like that. Sort of the same as you get on Windows on the T2 Max. This might work. And for the sequence numbers, I think these are per device. So we can just have these initialized here. Probably not going to use the receive ones. Did they start on 0? Did they start on 1? Yeah, start on 0. Actually, then I can just say iFace. Not even use the RX seek for now. I don't care about that. Yeah, the main thing is that like developing the API itself is the big question, right? We're going to provide drivers, so you're going to have like the standard Linux event device and frame buffer device that you can use. But there's sort of different levels of support for the touch bar, right? So I'm going to write a little daemon that just handles that and, gives you some virtual buttons and whatever. But if you wanted to do something like what macOS does, the right way of doing that would be making a Wayland extension that allows compositors to understand that there is something like a touch bar, like an auxiliary display, that allows applications to draw windows on it and draw things on it. Like there's, if you want to really do what macOS does, there's a whole ecosystem that has to be created. And that will require someone who really wants to put the effort into that. Alternatively, what is probably more likely to happen if nobody else does that is that I'm going to write that little daemon that does the basics, and then people are going to hack on it and make their own sort of, little extensions, and it's all going to live sort of, on the side, possibly interact with the desktop, but not, via like dbus or something like that. But, sort of not really be an API that apps can use to implement Touch Bar as a native feature. So for that to happen, there's a lot more sort of, design that has to be worked out first. But that's up to people who want to work on this. It's open source, right? We can't do everything. But yeah, if you wanted to do it the right way, so to speak, that's what would be the right way of doing it. Okay, so send sec message. So for the header, we have a pack on that, and it's just going to be 8, 11, and message. Sec, I guess. My face. We don't know what that. Oh, the padding's just padding. Yep. And then checksum equals. And then we have the checksum and self.dockchannel write packet. That should work for sending. Enable device self. My face. For this one, we'll just do self device control. We get device control message, which is a device enable message. Yeah. Something like that. Yeah, I think it's more likely that we'll just have some little like side daemons like that. Yeah, which is cool. I'm not actually sure if it's worth having like. I mean, it depends on if people are interested, right? But I'm not sure if it's worth spending the time and sort of having a proper app integration for the touch bar. Given there's so few laptops that have that. Though, of course, this will also work for the T2. Like any ecosystem, any touch bar ecosystem that ends up being made for Asahi Linux will also be useful for the T2. The drivers will be different, but everything on top of the drivers can be the same. So that much is not a waste. I just don't know how many people actually care about the touch bar. Okay, enable device. Yeah, we got that. And now we need to notification, device control ACK. Let's deal with those first. So now we have notification message, and those are one of these. Oh wait, that's not gonna work for is instance because it's not an instance. This one is, but this one isn't. So I actually just need to check if message header flags and C0. Actually just say type equals that. If it's 0, it's a notification. If it's 80, it's an ACK. And so for these, for the interface, let's do self dot initialize false. Ready message. Then we do self.iface message dot. Let's make a little log function here like these. Something like that. And then in proto, we can say def log self print. That's good enough for that. iFace by name, com, self, I'll just say, actually, I can just, just use a function for this because we need something to add interfaces. So let's just say add interface, iFace name, and descriptor. Or even get interface. iFace name. And so then if iFace in iFace returns of iFace else so raise an exception if we don't know about that. And for unknown interfaces, we can just log everything. And interfaces. Com interface. Oh yeah, these don't have names though, so I need to do that. Let's all of them. Actually, let's not make this an exception. Just make a log, return none there. And then I can just say that. So there's our COM interface. I'm going to make an MTP HID interface that doesn't implement anything yet, because I think a lot of them are going to have the same stuff. Actually, you know what? I can just say... yeah, you know what? Let's just say... Let's just set it directly as a name like that. Makes it easy. And then just list these here. So let's wait init and then have a wait. Yeah, we can use wait init and just have all the logic in here. So that's fine. So then when we have the notification, it just marks it as initialized if it's a device ready. Elif is instance. Actually, I also had a thing that was wrong here. This is not a HID descriptor, not report. So for init message, you have the type, subtype, unknown, device ID, device name, yep, and message. And then we need the proto get interface. And for the init messages, it will be for the blocks. There. iFace.descriptor equals block dot. Oh, it's not an instance in this case. I'm just doing it if... oh, that's a bit annoying. block dot payload. Yeah. Let's have an str for this. Yeah, something like that. And then we have the GPIO init. Not phase. So it would be self dot proto dot iphase device ID initialize equals true. Get it there, log. Okay, that should don't forget to add dash to underscore and multi-touch. I did do that here, the when I set item on local. But this needs the dash because that's how it comes in from the STM. Okay, that makes sense. And then when we have the descriptor, we can maybe at that point just actually do the init. Initialize. And then in the interface, def initialize self dot iface, sorry, self dot proto dot com dot enable device. So just enable itself. You know, this is supposed to have a dash because that's how it's going to come in from the other side. So otherwise it wouldn't match. That is correct. Okay. Yep. That did go to sleep apparently. Okay. Chain load. Yep. MTP. Okay. So let's see how badly this broke. NTP start. Dockchannel. Actually, do I have it like work everything, something like that? I think I would like that. Hardware ASC. Return handled false. Returns true if it's empty. Yeah. This is really just so that I can pull the thing for every time we do anything, really. Work pending. It's experiment stuff. So I mean, this runs in userland, but it's also just a prototype. It's a prototyping system. Work pending, and then okay, let's actually try this in the experiments. Dockchannel. So one thing I noticed, I think, is that it was actually like dropping messages if I sent them too quickly, which is a bit questionable. Oh, but that's because I was sending these inits before it was actually sending me the request, so that's okay. So let's just say MP the protocol UMTP DC, and let's just wait for the keyboard first, just to see what happens. Oh, not. Actually, just wait here. So I don't expect multi-touch to work. And finally stop the MTP, and hopefully that'll let me run it without reboots a few times at least. Okay, let's see what happens with that. Oh, I didn't even import. Oh, I did. I should not have done that. And it also crashed. Int object is not. Didn't I fix that? Do you have inconsistent uses of iTranslate? Oh. No, I'm just dumb. It's supposed to be like that. Almost. Ooh. Ah, because yeah, let's reboot this one time. That got out of sync on the Dockchannel. Ooh, checksum failure. Let's not log those syslogs. That's noisy. Am I doing that? Okay, yep, that works. So the checksum calculation is wrong. Oh, because that. Might as well just log it then. WD packet data, not packet. Okay, header. Attribute error. Message header flags. Why? Ooh, that's weird. Checksum expected negative. Oh, I'm not ending. Aha, okay, now it's not breaking. Also, I need to flash DC here at the beginning because I'm getting very confused otherwise. How do I have a thing for that yet? Yeah, let's initialize the DC first. Okay, now I just wait for keyboard, even though... okay, so maybe when we put it to sleep, it doesn't actually do the reinit, so then we have to reboot. I want to find out how to actually reset this thing. The thing is, we don't have a reset register for it, which is real unfortunate. Okay, so what was the other issue I had before? Yeah, header. Why? Oh, I know why. Yeah, because I need to actually create that. Getting there. DCMST. Where is that? DC message, not message. That again. Two arguments got 7. What? Oh, not unpack, pack. Okay, getting there. Now I need... I think I'm doing something wrong here with the lengths. TX message... Yeah, there's a length there. I guess we can just pad that here. Aha, okay. We got... Look, a lot of things initialized. That's good. So I don't know what the message type actually means. Ah, there's no last command. I need that. UC message dot command. Interesting. ACK for B4. Isn't that right? Yeah, device enable message. Why is that? Oh, yeah, there's we have a queuing issue here. That might work. Yes. Yeah, so it gets the descriptors, then those get stuck in like recursive loops until it gets the ACK, then it gets, yeah, sends the next one, sends the next one, that's fine. Yep, and then multi-touch gets stuck, which is what we expect. But I can type keys and the keyboard works, so that's nice. And apparently these are on type 0, which is interesting. Just do that. So now the actual multi-touch init. Yeah, some of that here. So these send init for 2. Yeah, I think it sends the init first. This is B401. Yeah, so it does send the... Or not. Yeah, so it sends the grape interface configuration immediately, but then it's not initialized yet. So we need this thing. AFE.bin. Let's just feed it in for now. Yeah, this thing. And that should happen after. So basically, in the multi-touch, initialize. We do the super initialize. First do the enable, and then the flags should be 80 on that. Length len, AFI message build, unknown 0. And then I need to actually map this to the... So that's why we need MTP, because that has the Dart reference. That's here in ASC. IO alloc. Let's try that. Ooh, okay. We did send that. And then we got... That's interesting. We got one of those null ACKs. But weren't those... touch initialized. Because those null messages are what we get when we initialize the other ring buffer for the replies, but I'm guessing we don't actually need to do that. Keyboard works. Oh wait, no, it's not a null message. We do have some data there. It's just 8,000 something something. It actually come in. Yeah, it does come in on device 1. You might need something. Okay, let's go from the beginning here. So it does all the inits first. Then it sends this device 2. That's the keyboard, though. We don't care about that right now. These might be the LED messages. And then it does the init immediately. Flags 80. Did I set that properly? Did I set the flags right? Yeah. I'm just realizing that I'm not logging the message types properly, and I should, because I might be getting those wrong. Yeah, I'm not logging them, I should, because I think I'm getting some of those wrong. Let me fix that in the tracer. Trace MTP. Yep. mtype dev ID counter and packet. Let's see if I can add that again. Oh. mtype? Why is that a str? Oh, I have more than one mtype. Okay, that should be enough of a log. What do I do here? For type 12, yeah, okay, so the incoming is 12, we send with 11. Okay, so the type 11 are the ACKs. Oh, and we do send with 11. Yeah, but that's fine. What about the AFE enabled thing? It does send with 11, so that's not special. And it does have the transport initialize thing right after that, so we're doing something wrong if that's not coming up. And mtp.py. Dev1. Yeah, that does get sent to dev0. Oh, hold on. Am I doing that right? I might be sending it to the wrong thing. I think I'm sending it to the wrong thing. Right, it's not self-send. It's protocom send, which actually should be init AFE. I'm guessing that UNC3 is probably interface. And then I can just move that over to the top. Yeah. So in com, in init AFE, just I guess that's the interface. Yeah, that might work. Getting there. Ah, okay. Yeah, we do get those messages, and then we get an ACK for 95, which is 95. Oh yeah, because this is a device control message. I'm done. So then yes, I can just. So I don't know if this actually means that we're gonna get touchpad data already with just this, or if we need some more stuff. I think we need some other commands to actually bring it up. Okay. Yeah, nothing yet, but at least you got somewhere. Keyboard does work. Okay, so after that, gets the ACK. It's sending something to device 0. 40. I don't know what 40 is. Since device control 40, 110, then 112. None of those are GPIOs. And then there's a touch reset X request. Okay, so that's the touch reset thing, yeah. Oh yeah, now there's some calibration blob stuff happening. What about the GPIOs? Okay, let's actually, I'm going to do a trace with SMC, which is going to be very spammy. But I want to see when if it touches those GPIOs, when it touches those GPIOs. Because it probably has one of those messages to tell it when to flip the GPIOs or something. Yeah, very, very spammy. I think it's done. Yeah, it is. And so we're looking for GP08 and GP18. Aha. Oh, look, touch reset X to request OK is literally coming in when that GPIO flips. That's interesting. Though I wonder if that's just a coincidence in how the things are processed, because that doesn't make sense for that message to really come in there. I think it just means this is probably the actual request. Because it's a notification, which is what I would expect. And so then I'm guessing this is the ACK. The C1. So we get device control 1.1 and then device control 1.1.2. Let's try sending these then. Command 40. I'm also going to get one of these as a device ID, possibly the first one. Just a guess. 40. Then we have device ID, unc1, and state. I wonder if this is could be something like wait, flag 0 on dev 0. Is message type A0. Yeah, probably device ID. And then maybe this is like a count or something like that. 167? Because the GPIO stuff, A7, so we had one A7 as AFE reset. Yeah, look, A7 is there, right? Yeah, so that has to be a GPIO request. A7 is one A7 AFE reset. Yep. So I don't know what 3 is, but so we're going to define a GPIO request message, call that message type A0, device ID, GPIO. Func2 would be GPIO num, I guess. GPIO name. We don't know what that one is. Could be the device, but I'm not sure why it would be there again. Oh, no, it's not, because system address is the same. So, could be an index. Or some kind of flag. Yeah, this is probably some kind of like command or something like that. And now I need to get the GPIOs actually parsed here. Function AFE reset. I forgot how these are marked. Name, yeah. That'll do it. Not name, sorry. Args 0. Yep, that works. Be right back, just give me a sec. Sorry about that. Just had a little glitch there. Okay, back. Yep. So let's get the GPIOs done. So in here, if this is a GPIO init, we can first in the interface make a little thing. Let's say unc2. Which in this case is GPIO ID. Do we have a node thing in the ASC that I can just use for that? That'd be nice. Oh no, but it's not the ASC, it's the Dockchannel. So I need the Dockchannel node. I think I do have that one. Or not. Oh no, because we did it straight from there, yeah. I guess let's put it in here. Is it HID transport? MTP transport. And then the GPIOs, I can get node equals proto node name dot get attr. And then I need the underscore. Something like that. Then it's arg0. This is my prop for here. And then we need the SMC too. Which I am not initializing right now, and I do need. Okay, so now in yeah, we get that, and then when we actually need to handle it, message type, device ID. Actually, just say key equals. This should be big endian. And then we do a write 32 of that with I forget what that bit meant. Was that the inversion bit? The ADT has, I think it does have that bit set. Yeah, it does. So I think we can just do that. This is the proper way of doing it in macOS. Right, 32. Oh yeah, this does come in dev 0, so yeah. And just store it in itself then. So it would be device ID, GPIO ID. Something like that. Okay, let's see if that works. And now we need to actually send these for it to work. So we send 110 and then 112. These are the reset device things. Device reset message, unquan state. Command device ID unquan state. Okay. Device control, our message, and then in the multi-touch interface, we do init AFP protocom device reset, self face, and then we send it a 0, then we send it a 2. Both of those are ACKed. Then we should get the GPIO request. And then there's this C1. Then there's that extra protocol thing, which you don't need to do, I think. So I don't know if this is the ACK, actually. This might be a GPIO ACK message. It's ACKing. It gives it a 2. There's no 2 here, though. That's a bit questionable. Or it could be, if it's a device ID, then this might be a keyboard-related thing. Yeah, that's probably not that. Because if it's an ACK, I don't know what the 2 is if that's an ACK. Yeah, so then there's the buffer story, which you don't actually care about. And then we get something longish. That looks more like an ACK for the device thing. Oh, but this is interesting. This is getting... Oh, no, that's just a null message. But then that goes through the buffer. Yeah, that's just the buffer. Yeah, so this is the transmit, sorry. So there's nothing in there. Then it sends this. So we don't know what that is. Is there a 1 A7? Wait, isn't A7 the GPIO ID? Oh, okay. So this is the ACK. This is the actual ACK. Okay, that makes sense. I think there's several things happening in parallel here. That's why. Okay, so then A1 is the GPIO ACK message. And it's more like A01, A703, length 14. Yeah, it just sends the whole thing, right? Yeah. Command A1. Yeah. So A1 is an ACK message. And then we have those 4 bytes from the header that we don't know about, the UNC. Actually, I can just say message. Just pass it like that. ACK message. So device ID? No, wait. ACK message is... It has command unc and message. Okay, that makes sense. So there's our ACK. Which also gets itself ACKed. And then... this is another keyboard thing. I don't know... This might be unrelated, because it's sending stuff for the keyboard, and... I think this is just autonomous at this point. Let's just see what happens. Args greedy bytes. Uh-huh. I face unc1 state. Did I actually call that right? So I face unc1 state. I think I missed something. Yeah. Yeah, 112 and 110, right? Yep. Okay. Yeah, that's wrong. GPIOs. Uh-huh. Touchpad works! Yay! We're done. Okay. So just finally, I need to actually differentiate these HID reports. Let's actually log that. So when we get those reports, those are ID 12. Is that right? Yeah. So it looks like channel 11 is the command ACK channel, and 12 is for what is 12 for? The descriptors. Yeah, it's for like notifications. So what I want is yeah. So what I probably want to do in Linux is have two queues, one for notifications and one for command complete, and put these messages in the queues, and then always process command completes first, so that we don't get into weird parallelism situations. This is probably going to be a lot more sensible like that. Does it support the force feedback? I think it should be. Actually, let me try. But I think by default it does that. Like macOS controls it itself. Yeah, it works. It's basically in like mouse emulation mode right now. So it does the force feedback by itself. It doesn't do the double tap though. That like when you hit harder. It's the same thing as we have on the M1. So there's other modes you can send to control the force feedback directly, but that's going to be the same as on the M1. So that's a different driver. Like this HID stuff for the touchpad is an existing Linux driver we're not going to touch. And that's where any force feedback stuff would happen. So because as you can see here, what I'm actually doing is I'm not doing anything with the actual multi-touch interface. Everything I've written right now is magic that happens on the COM interface. That's the only thing that's going to be in the in this like transport driver itself. And then all the other interfaces are just standard HID devices that get passed down to something else. So that's fine. So yes, I just want the that's device 1, 2, 10. Yeah, it's just the length. And that's probably the report ID. Length 2. Yes, I know it's controlled by macOS, but it isn't controlled by default when you don't do that magic in it. So in this case, it's being controlled by the hardware, which is the same as on the M1. That was already the case on the M1. Yeah, so there's like a sequence number there. And then I guess it's a report. How is the keyboard? Let me just run that again and get some keyboard samples, make sure this makes sense. Yeah, so we get those two inits. Oh, interesting. So Shift just gives me keyboard, but like function does interesting things with the touchpad for some reason. And also caps lock. Yeah, so I'm assuming that's the report ID. So these come in as type 12 on the other devices. Is this actually the same header? Flags, length is right. And then the unknown one. Yeah, so it is the same header for the HID reports. And then you just get the HID report after that in the case of that. So in that case, we can move this to the common code. So this is com report. Actually, no, it's just a notification message or device control ACK. Yeah. So in that case, for RX message, let's just do a greedy bytes for that and move this to the other code. I'll have to move this in the tracer to something else, but for now, I guess just do it like this. So report packet, yeah. So packet, it's this report, msg packet.message. Unknown. Is this code open source? Yeah, of course. I mean, it's not pushed yet. How's progress? The touchpad works. I'm just cleaning up a little bit before moving on to the next code. So report is where I want to do this. And there's not notification at that point. It says report. And I should just do not mass control message. Sorry, notification message. Then we don't need that. Oh, we do need the ACK. Okay, let's try that again. Greedy bias, I keep doing that. Self-report. Got ACK4. It's not message anymore. Aha. Yes, and I get multi-touch reports. I can use the keyboard. And the multi-touch. There you go. So the descriptors should have that stuff. Is there any, like, I know as USB can do it, but is there any handy HID descriptor parser? Yeah, you can paste text. Cool. Separated by commas. Okay, so it wants a hex dump of that. So I can just say, do I have a, I think I have a hex dump I can use for that. Details, hex dump sep. Yeah, it does have a sep. Cool. So just do sep log hex dump. Let's make sure that I actually have that right. That's the what is the descriptor and what isn't. Is this Python code going to be written as an SQL library? Yes, like right now, like literally as soon as I finish this. Like literally, as soon as I confirm that this report stuff works, that's what's coming up. The power button is handled by SMC, by the way. Oh, I just killed the USB, but yeah, no, like you get an SMC notification. The power button already works, so that's not a problem. Anyway, here we go. The reports. So, for the keyboard, that's a long report for the keyboard. That's interesting. Yes, so this is obviously a correct descriptor. Report ID 1 keyboard. Cool. Report ID 82 application. There's play pause. Okay, so for some reason it has the yeah, this one obviously doesn't have those buttons, but I guess some of them would. And then there's a vendor defined thing. And some other random stuff. And then the multi-touch. Mouse pointer. Report ID 25. Touchpad. Report ID 63. And what was I getting? 75. That's a bit weird. Because we get 60, 52, and then... But there's a length here. It looks right, though. That's not a length. That's... I mean, this might already work with the existing driver. I'm just a little bit confused. Because I was expecting some other stuff. Yeah, so the keyboard just says 1, which is the report ID. Yeah, and then it's count 8. Yeah, this is the key, so that's correct. And then it has the other stuff in there. So that's fine. I'm actually curious about these accelerometer and stuff. Vendor defined. It's just data. Yeah, this just gets data. Report ID minus 64. That's interesting. For actuator, yeah, it's just like vendor defined randomness. And for the STM, same thing. But for multi-touch, yeah, I would expect some level of standard reports from this because there is a HID descriptor, so but we have 63, 1, and 68, and that's it. But then you have 60 and 52, which are different, and 75. Now, let me just look at the Magic Trackpad driver real quick. I think it's this one, Magic Mouse. Or not? I get a 2. Yeah, I get the feeling the hit descriptor is kind of BS here, but then I don't know. So that 1 looks like the mouse thing. Yeah, port ID, buttons. Oh, that one looks like it's this one, actually. Yeah, that was that one, because I see the buttons there. So this is the mouse report. Probably. Or not, actually. 6.4. Yeah, okay, multitask protocol has to be explicitly enabled, but I haven't explicitly enabled it. I'm already getting it. So, or is what I sent earlier the enable? What happens if I don't do that? Because obviously I'm getting multi-touch here. Because what's going to suck if this is another HID level protocol that I also have to add support for. MTP. Maybe it's the set interface, what I just did there. The reset one. What if I don't do this? Because that set interface 0.2 would make sense. So if I don't do that, what happens? Does it actually do the GPIO request for me, or? No, it doesn't. So what if I do 1? Does that give me the regular mouse? Oh, interesting. That stops it. Okay, so 2 is quit. What if I do? If what happens if I just do a 1? Yeah, that says AFP transport already stopped. Also, why that delay? It doesn't happen if I don't send any messages. If I just send the 0, what happens? Nothing. If I do a 3, is that a thing? Actually, if I do 0, 2, is that a thing? No. Just gonna try some random stuff, see if anything interesting happens. Ooh, enable STM reset via HT tool. Interesting. Okay, so that's... Oh, wait. So the device ID is this one then, because 3 is STM, isn't it? Yeah. Then maybe the other one is the report ID? So 0 doesn't do anything. 1, 2 sets it to running. Invalid blob force touch. Invalid blob. Interesting. Cumulus crash detected. Oh, nice. Okay, so what we actually got now is that's a stop, that's a start on 1, and then set report failed. Okay, so there's a set report involved here. Doesn't like 2. I'm gonna try all of these, see if that any of these do anything. Looks like all those are ignored. What about like 5? That also doesn't do anything. Mm. Yeah, so 1 is like a stop. And 2 seems to be a start. I don't know if we need 0, but yeah, that works. So we only need 2. So this looks like set report, but like report type 1 doesn't seem to be supported in that case. So what happens if I do the keyboard? Which would be 212. Does that change? Because didn't we have some reports in the keyboard? Port ID 1. There's a report ID 82. And then 63. What about the accelerometer? What reports did that use? Can I just turn that on, see what happens? Will that give me accelerometer data? C0 apparently is that one. And that one is 5. What about Z02? Doesn't look like it. What was the STM one that we had? STM is 3. So if it's 3, 1, 2, is that going to do something with the STM? Oh. Yeah, 1 sec. So let's see. Yeah, so that definitely does reset there. Does 2 do anything? That doesn't look like it does anything. Okay, just for fun, after the AFE, let's just do a ooh. Oh, the TX seek. Yeah, I need to. Okay, so what we have is 0 doesn't do anything. 1, 0 doesn't do 1. Yeah, so that's the one we already know about. Set report 154 fails. So the 154 comes from somewhere. So maybe it's just internal. Yeah, it's 9A. Isn't that one of the ones from Magic Mouse? No. Maybe it just doesn't support the legacy mouse format anymore. Oh, interesting. This gets keyboard reports, so... Oh, all of them, actually. Where did that come from? Yeah, so it's clearly device ID, and only really 2 does the reset thing properly. And everything else is ignored. I'm gonna try all values for the second one, just in case it's a report ID. And I'm looking for 255 here. That's gonna take a while. Yeah, so those are as expected. Okay, let's do it a bit from 2 to 10. Just do 4 here or 3. Yep, the STM reset one. Nothing else. Yeah, so it looks like only those really matter. Okay, so what else is this doing? Didn't see if the command is used anywhere else. Device reset is 40. Nope. No, but this 6002 could be set report. No, but it's a receive. That's on dev 1, so that's just the message coming in. So is that that's this one? Is that just like current report? Okay, let me just look at that magic mouse code again, see if that matches everything else. Set report is 9. What are the keyboard stuff that happens earlier? This does 100 like multiple times. I don't know why it does that. It has those flags, so that kind of sounds like that. And then yeah, so 40 sounds like set report or something. That's the set LEDs thing. 102. What was this? HID Apple, was it? Oh, the keyboard? Yeah. It's the backlight, but that's not what I want. The keyboard LEDs is using a standard thing. Let me look at the descriptor again for that. There should be an output somewhere. Ah, there. That's report ID 1. Count 1, size 3. Count 6, size 8. Const. Yeah, so that it should be report ID 1, which is the same. Yeah, so that should be set report. The 40 should be set report. And it's only ever used for the LEDs. So it's interesting. It says... So that's actually the init thing. It does 3 set reports, which kind of makes sense because there's 3 LEDs. So there's probably a dumb loop somewhere that is like sending the set report 3 times. Oh no, it's only twice. So it then comes back at type 11. Yeah, I don't know then. And it looks like it just gets ACKed. Okay. And so what about set protocol? That's B. Yes, none of that. Okay, I'm going to look again at the spy one, see if there's anything interesting here. MT mode set protocol, that's 52.2. Caps lock LED 51.1, that would be set report, yeah. Yeah. So nothing terribly interesting there. Info management. Descriptor. Yeah, so we have set report, output report. Yeah, so we don't really know what set report is in this case because that reset function does look like an actual reset function. And hmm. Yeah, so then enable multi-touch. No, but this is somewhat related to one because in this case, or this is the HID stuff. Yeah, because in this case, the keyboard is device 1, the trackpad is device 2. And then the spy one is doing... report num not equal IDEV ID. Is it supposed to be like that? Yeah, there's clearly some confusion here between device IDs and report numbers. Then this sets D701. Oh, but this one actually has two IDs and then... Yeah, I'm not sure what that's about. Request gets a response length, buff length, yeah. And some device ID redundancy here too. Anyway, the report IDs. Oh, okay. There's something for spy here. Conflict with the report ID. So that expects this one. Expects 2, which is that. Yeah, that was number 2, but we're not getting that though. There's a 2 there. But then there's a 75 in front. Wasn't there... I may make sure that I'm actually printing that other thing. Yeah, because I'm not doing anything with the flags right now. I need to do that. I bet I'm missing some data there. Self portal log? No, just self log. Why am I doing self portal log here? Uh, those are all zeros, so that's not useful. So what data are we expecting here? We are expecting let's see if the touch format is right. That's XL, right? And Y. So this looks like Y. This looks like X. Or is that rel? No. So it looks like X is right, and Y. Yes, it's XY after the like FF thing. Yeah. So it's like an unknown byte, and then which is probably the touch ID or so. Then XY. Is that right? Yeah. Hold on. I keep confusing myself with this. It's so part of it is the lag, because it does lag a bit, because the report's coming too fast for the decoder. Let me comment out some of the logs. Get rid of the FL. I think it's the same format, but I need to convince myself of that. Report. That's at the end here. Yeah. That's a bit better. So that's moving horizontally. So X and Y are here in the beginning part 2. Yeah, so this is the count, by the way, that one there. That's the touch count. Then there's some other stuff. Okay, here's the X. It's little endian. So this one is more like what quadrant we are or something. And then this is actually the X. And then the Y. Yeah, okay, so it is XY. This. Does that match the format? And then we have other stuff. This is how long a single touch is. Weird. So there's... It doesn't quite add up. Oh, this is CRC? Hmm. Okay, the click thing is right. So there's num fingers clicked and then 14 bytes. Okay, and then we consider that part of the button data. Yeah, so that does add up. What about the stuff before that? So we have this before that. There's 22 bytes of unknown. 16. Aha. So it's just the vendor part. So there is no mouse report in this case. So unfortunately, that means that this has to change. Yeah, so this is probably going to work as is. It's just that I need to skip over that. But data 1 is definitely not going to work here. Okay, let's make some edits for this so that we can actually test this when we get the transport going. Um, I have the feeling that these unknowns aren't quite right. Like one of them is probably the CRC or something. Not clear. There's no CRC this time though. There's always zeros at the end, so. Let me just get one with 2 touches and break it down to make sure this makes sense. So here's one with 2 touches. This is with no touches, and assuming we start here. Wait, what? 3 touches, sorry. Here's one with 2 touches. Here's one with 1 touch. And here's one with 0 touches. Probably just pad it to 32 bits then because of the way this is adding up. Yeah, because there's always like zeros at the end, and yeah. Let's try one with 4. Yeah, it's just okay. It's probably just aligned to 32 bits. Um, sure. Okay, I'll buy that. Oh, we only have that with SPI. Okay. What about the USB ones? How do those work? It uses endpoints, emit touch, data plus II data, looks for the report. Yeah, okay, so the SPI one is specific. The other issue is that what's our bus? This is Dockchannel. Like, do we have to make a new bus or is it like special or what? Oh, it's under U input. Ooh, okay. That's going to be annoying. So we're gonna have to add the UAPI for this. Oh, that's kind of sucky. Hmm. Or is this MTP or Dockchannel? The bus is Dockchannel kind of, but uh, it's not really a bus at that point. Honestly, this should just be like a bus platform or something at that point. Okay. Hit type spy mouse. Why is that? Why is that like that? Uh, why is this a thing? And why is this USB mouse none? What? It doesn't. This enum doesn't make any sense. And there's no spy here at that point, so. Ah, but this probably is fine with the same one. It's just that for the raw events, I need, yeah. input. I don't need input. I need the header. Don't need the finger. No endpoints. Header size. No, and then there's that padding, which in this case, it's, yeah, that's not good. Because there's no length, is there, that actually does that right? I am getting the... I am cropping that arm. Oh, am I? Flags length unc. Rx message parse. Yeah, message. And for message. Oh, no, I'm not. Okay, I need to do that. That's probably what the... Yeah, okay. So that should fix the padding. That's good. There's 2, there's 1, there's 2. Oh, those are both 2, and there's 0. Okay, yeah, that... no more padding, that's good. Yep, okay, that was... Yeah, it was this randomness. Okay, so in that case, for the USB, we check the report ID. We can do that percent check later. So size is less than header size, TP header. Let's call this TP mouse report. Yeah, so just skip over to that for this one. Oh, standard. Did I typo that? Yeah. I can just do TP header, I guess. See that as TP header. And then we drop that. And that should be fine. And then it's just that this can't be data 1 at that point. It needs to be clicked, or just buttons. Okay. I think that will work as far as the SPI stuff. This will be MTP. Most of the battery stuff. And I guess for this one, we don't actually need to do that. Okay, I'll buy that. I'll go with that for now. As far as the downstream HID driver, might need some ID stuff changed, but then basically that, and then do whatever the SPI thing does to initialize the devices. How did this handle the device IDs? Gets interface info, gets the descriptors. And then there's a vendor ID. Device info, vendor product serial. Yeah, we don't have that, do we? um, is there anywhere in the logs I have where I saw the Apple vendor ID or something? Oh, it's just 5AC. Okay. I don't think we saw that anywhere though. Nah, I go straight into the HID report messages after the GPIO stuff. There's no global device ID stuff. So I guess we just hard code those. But then how does this probe? I guess it's a spy, hit spy device. Yeah, well, yeah. Yeah, but there is no hit descriptor for the management device in this one. Unless STM has it? I don't think so, though. No. There's no 5AC here. So yeah, that's not a thing for this one. Just 1 second, be right back. Okay, back. Yeah, so I guess we're gonna need something special here. Is this a thing? Like, are there any that actually match on these? What's bus host anyway? Oh, is that what it? Oh, is this what I'm supposed to be using? I guess this is what I'm supposed to be using, because this was used for all the laptop, like, weirdo stuff. And technically, this isn't the host, so yeah, I guess I'm supposed to be using bus host. That kind of makes sense. Yeah, it's used by Apple SMC2 and that kind of stuff. So yeah, let's avoid that. Let's call it bus host, and there's no hit. That's not a thing. So how do these work, for example? Oh, it's just hit device. Okay, yeah. Oh, there's hit group. Interesting. Um, so what are the groups? Interesting. Multi-touch. Yeah, I guess probably a bad idea to use that. Is that in the descriptors? I don't think so. I do remember a 1, though, in one of the... because this HID descriptor is... I had type subtype length. Oh, but no, that doesn't make sense because... Actually, no, it does kind of make sense. Kind of. Yeah, it could be that. Not sure, though. But yeah, I was getting, subtype 0 for this one. Oh, no, it was 0, yeah. And then I had 2.6 after that. Yeah, so if it's 0.0, that's not useful. So let's just say bus host, there's no host vendor ID because that doesn't make sense, of course. Is this anything matched by host vendor? No. What about this one, though? Intel HID. Intel HID events, key map. But it's literally just like button arrays. The boot ROM can... oh, you mean the DFU mode stuff? I think that must be something special. I don't think they're using the regular keyboard driver for the DFU mode. I'm pretty sure the DFU mode... there's probably some special, like, wire or something that returns that, and it's handled autonomously by the ST on the trackpad, because it doesn't make any sense for the boot ROM to actually do any of this. It can't. I mean, it doesn't have the it doesn't have the firmware. So, yeah, no, I'm pretty sure there's a sideband for the DFU mode magic, and it's probably just the Y. Actually, I can find out. I have some of these things, and I bet if we look at trackpad connector. This is for the old ones, but I bet it's the same. There's no DFU specific thing here, but I bet there's something. Oh, there's a keyboard SDA and SCL. That's kind of interesting. IOXP, I2C SDA, 2 from trackpad. Oh wait, this is literally. Oh wait, the keyboard driver is. I thought this was on the trackpad on the other Macs. Keyboard signal connector. Hold on. See, left option key and control key and right shift key are aren't those the DFU keys or so? Yeah. Yeah, see this one. Right option key, left option key, and control key have dedicated lines. And there's an and RS lock RST. Yep. So there you go. You see how that's done. And it's going to be something similar on this one. There's either going to be dedicated lines on the trackpad or whatever, and yeah. That's interesting, though. I didn't realize that they had the keyboard. I thought the keyboard controller was in the trackpad. This one's on the main board, though. But then it goes back to the trackpad and actually routes through it, which is also weird. Don't I have the... Yeah, I have the MacBook Pro, actually. Trackpad. Oh, yeah, it is also on here. That's interesting. You just see if there's any trackpad shots on this one. Doesn't look like it. So this one does have just one connector. Interesting. I thought there was supposed to be a separate connector for that one. Yeah, there's a separate connector for the... That looks like the keyboard, so yeah. Huh. Yeah, so the... Okay, so the Pro and the Max have it separate. Okay. Is the area the same? SPI bus level shifter, SPI IPD mostly connector. Where is that? Oh, there it was. Ah. Yeah, this one doesn't have the keyboard on the main board. Yeah, and see, here's the RS lock line. So this one has the keyboard controller on the trackpad. That's interesting though, because I thought the trackpad on the yeah. See, this one has. This one clearly has the keyboard connected to the trackpad. So wait, are these? Hold on. Oh, Pro and Air. Okay, so they are different. Huh, so the Pro has that. One second. I'm just gonna check an email because I'm kind of curious now. Because I thought the trackpads for the M2 and the M1 MacBook Pros were supposed to be identical, visually, but that now doesn't add up. So just give me a sec. Just one sec. My email is loading very slow today. Well, the server is in Europe, so. Oh, okay. Then I just kind of misread this. Yeah. So here's the M2 trackpad, and it does look the same as this one with the one single connector. So it looks like, yeah, on the Pros, the keyboard, I guess multiplexers are on the main board, but then it still goes through the trackpad to actually communicate. That actually begs the question whether it does that at all on the M2, because now that the now that the main controller isn't even on the isn't even being done here, then kind of, I wonder if they even did that. There was a thing in the firmware. Anyway, I'm kind of getting distracted here. So yes, the DFU thing is a special case. So the question is, does macOS actually list any IDs? Let's do that. Let's boot macOS, see what it thinks about HID, and whether it gets that from anywhere or whether they give up from that. Let's see what IODev says there. Might as well trace all of that, see if we get anything interesting there. And I can also just run some random things. I think that's the IP. Oh, did I just break the HID reports there with like a... I think I just broke something. So I was getting raw hex stuff there. Yeah, what? Oh, yeah, because the RX message thing isn't doing that anymore. Yeah, it's okay, though. Yeah, I just need to fix that. It keeps forgetting my settings. Reg. So what do we have? Not Mesa Shim. Hit transport device spy. This is the Touchbar. Yep, grape. I guess they call that Broadcom thing the grape. Because they both talk about that. Yep. Okay, now. Oh, interesting. There's yeah, it's not the. Okay, SPU HID device? No. Accelerometer is on there. Gyro. Yeah, these are the AOP ones. Not those. Ambient light sensor. No, not those. Okay, MTP. There we go. So there's a dock channel. It gets the downloaders, which is a bit interesting for multi-touch and STM. Yep. MTP sys. Hit transfer device FIFO. Okay. Memory FIFOs. Yep, it has that thing. What are the GPIO? Is that one? This is under MTP transport, yeah. SCM FIFO. There's the RT body bootloader, firmware service, RTP, yeah. So this is hit transport. Yeah, there's COM. STM has that bootloader, hit device, FIFO. External resources, STM reset 168. That's what we saw there, those requests. So let's look for multi-touch. That's the interesting one. Hit descriptor. Yep. Merge personality. Interface type. Reporters. Multi-touch. Yep. AFE reset. Bootloader. Then transport HID device. Manufacturer Apple. But there's no ID. Location ID 166. I don't know if that's relevant. Primary usage 2. And then this is just the parsed HID report, isn't it? Look, vendor ID 0. Empty device ID 166. What were the ones we had there? 343. Yeah. Yeah, product ID 0. It looks like they just kind of gave up on IDs. Which is a bit unfortunate for Linux. What's 166? A6. Did I see any A6s here? Hmm. Isn't that just the reports? Yeah, that looks like the device ID actually, but that's not terribly useful. Let me just dump these IRQs because they're useful. IO registry planes. There's no HID, so I can probably just leave it like that. Yep. And I can reboot this. Actually, you know what? Let me do a normal reboot so that it saves the temp settings. And that way we can see if it does anything during shutdown, which is also interesting. Yep. Oh, now we can see how it shuts down, actually. It uses power 0 for everything, and then sets CPU control run 0. So you would think that would work for shutdown that can come back, but it's not clear. I feel bad I didn't break the parsing here. Yeah, but it does a bunch of commands. Command 21, command 2. Whatever that one is with the weird thing there. Oh, that almost looks like an error code. That looks like an error code, and it's returning an error to that. Because I think Apple error codes tend to look like that. And this is all in returns. Oh, okay, that makes sense. So the device control messages return an error code if it's failed or something. That kind of makes sense. So if I run that again, I wonder if that'll tell me anything interesting about the device controls. So in this case, the ACKs here, which comes from message.unc. And then I can try just doing all the resets again just to see if I actually get errors for those. Oops. Invalid. 0x. Yeah, see, okay, we get the errors. Okay, that's cool. So I know which ones are valid and which ones aren't now. So 00 is not valid. 001 is not. So he turns 2C2, then I get 2C7s for device 1. Two is 2C2. Yeah, so 1-1 works actually for anything 1-1. Then 1-2 is 2C2 again. 2-1. Yep, and then 3-1. So the second value always has to be 1. Yep. Okay, so that answers what the unknown is. And that also tells us that it really only does work for 3, for STM, and for oh, and look, for yeah, so for this one it's only 0, 1, and 2. And for this one it takes anything, but looks like only 2 actually does anything. The others are just ignored. So yeah, okay, there's no other interesting commands in that range probably. I'll just do all of those just in case. So this isn't set report because that doesn't make any sense. Oh, wait. Three works. But only 2. Oh, and 1 does take everything. Apparently. But again, only 0, 1, and 2 do anything. And 0 doesn't do anything. Okay. Mm-hmm. And yeah, 1C6, I think I thought I remember that in the device tree. No, actually, no, that's the P handle, but I think that's a coincidence. So I guess not. Yeah, I think they just gave up on that. Touchbar user device does have a vendor ID. Keyboard backlight does have vendor ID. There's a HID keyboard, top case driver. There's no product ID. Yeah. Yeah. I think we're just gonna have to make something up. So yeah, I guess it's App Remember Pro 13 2022, I guess. But yeah, since we don't have anything else here, I can't come up with anything better than using the device types T493. .493, and was it 413? I think. No, was it? Yeah, 413. So yeah, this also does mean that we need to start putting more stuff in the device tree. So we have the dock channel with the channel 0 hit transport. We also need the IOMMU, which is annoying. And then we're basically going to have to clone what Apple did with their device tree because we need to basically have the same kind of structure here. So can we do dashes in here? I think so. Yes. Was there a standard firmware binding thing? I think there is. I think there's a firmware binding. Yeah, firmware name. Are they not supposed to have directories? Some of them do, though. Yeah, they do have QCOM names and stuff. What do you call this? I think it's supposed to be called grape. But I think it both called grape, so and this will have to move to the actual like J whatever. Why is that file not open? J493. And then we need the GPIOs. Was GPIO names not a thing? How is that supposed to work, actually? Oh, that's not very, yeah. Was there names for GPIOs? That's a bit unfortunate. I was hoping for a GPIO names thing. Yeah, it's just compatibles. That's not useful. Yeah, so I guess then we just call it X GPIOs or something like that. MTP. There's SMC. Wasn't that? Yeah, there. Oh, it can just be GPIOs? Okay, that works then. And so the ones that we need are 8. Well, is that the inversion flag? Let me check that real quick on SMC. I think I have that somewhere. Or maybe not. Was this in Linux? No, but I didn't have the inversion there. Where did I put that? I knew about that at some point, and apparently I may have forgotten that. But I think it is, because well, I can find out real quick. Because the backlight is 18. 18, 1, 0. Oh, no. Not 18, sorry. 18 is 1, 2. Yes. That's the backlight. Yep, that's the inversion bit. Thought so. Okay. So in that case, this is active low is what I want. Which is usually what you expect for a reset, so that makes sense. 08. And then we have STM. Oh yeah, but then we have a lot of HID devices, so which one's which? I'll just make stuff up. But this one is 18, which is 16 plus 8, 24. Unless I just call this like that. I'm not sure if that's sensible. How does, for example, GPIO escort C work? Is it just like yeah, okay, it's just per pin basically. So in that case, that does kind of make sense. Is there any proprietary stuff? Some of them have proprietary prefixes, yeah. I'm not sure if that's required for GPIOs, though, that it might be. Oh, that doesn't even get used anywhere. Oh, great. Now we have a bunch of stuff that isn't used anywhere. That's lovely. Is anything gonna actually... Oh, yeah, it does actually do, with the prefix, yeah. Okay, fine. So yeah, I guess we just make some stuff up here for now. Then how do we bind the driver, though? The driver is binding to anything with spy, and then it checks for mouse, right? So how do we do that? Hit type spy mouse. Spy mouse. Or should we be using the HID groups? Because these kind of look like made up. Are these actually defined anywhere? Oh, it puts it in the parser. Oh, is that here? So in the actual spy thing, how do you set vendor ID? HID vendor product version. This is HID device. Yeah, register HID device. Was this actually added for Yeah, okay, you added that. Is this upstream? I don't think so, right? Uh yeah, we're gonna have to talk about how to actually do this in an upstreamable way because I'm not sure how it should be done. Um Ooh, also, how do we tell apart ANSI, ISO, and JIS? Because that used to be that used to actually be in the report. Wait, where was that? Because that was in the USB has a field for that. How did we get that? Is that in the keyboard descriptor? Where's the... Because I remember I could get the keyboard type from here, not the cable line calibration thing. The type, but where does that come from? I mean, vendor product serial. Where isn't there supposed to be one more thing? Like the layout, the country, or something? Oh, it is there. Spy hidden interface info country. Um. Okay, then I need to know that somehow. I mean, the KB line calibration kind of tells me, but what are the country codes? I had those in my Asahi Calamares configs thing. That's the iFace info thing, though, right? Which is not the descriptor, I believe. This is an actual thing, right? Like it's not the HID descriptor. It's some other descriptor, right? And it was 2D, OD, OF, and 21, and I'm expecting OF for this one. Yeah. Looks like that's gone too. That's also unfortunate because the installer kind of wants to know that. Uh, does the ADT have that anywhere? Not as that, nope. Non-Apple or untrusted code equals 1. That's a thing. Um, maybe that's gone. Maybe we have to interpret it based on cable line calibration, which is also annoying. Hmm. Quite possibly, yeah. Yep, keyboard trackpad, no country code. Funny thing is that one is under STM. Yep, 0. That's annoying. Well, we have to stick that in the ADT somehow. I guess Mini will have to calculate that based on the cable line calibration, because I don't want to lose that. Okay, I guess we need to write a driver now. You know what? Should this be a multifunction device thing? No, but it goes by channels. It's not really MFD. Because these are detected dynamically, so that's not exactly what we want. Is HID a thing in device trees at all? Is there a thing for that? Just this generic one, so I guess not. But is this compatible looked up anywhere? No. What is that one done? Doesn't have that. It's in the generic driver. Yeah, I'm just trying to figure out how I want to represent this in the device tree, because it's kind of it's kind of a bus, but it could kind of be an MFD, but it's not really MFD because it's just users of these channels. It is a bus. It isn't? Input is a bus. Actually, no, wait. How does that work on Linux? Yeah, there's a lot of random things here, right? There's nvmem. I guess, yeah, there's a bus type thing, right? And then we declare a bus type. Yeah. Yeah, it should be fine to create a bus type for this in this case, then, yeah, I guess. Yeah, I know there was HID. But this is not for HID, this is for Dockchannel. Yeah, there's enough bus types that we can afford to create a new one. So what I want to know is then how do we do the device tree stuff to probe the child devices? Um, mm -mm. Yeah, OF platform bus probe. Populate, maybe? There's not really platform, though. How does this work for, like, I squared C? And then the other thing is if we're making up, like, if this is going to be... Oh, no, well, yeah, we don't care about... Yeah, what do we do? Because if this is going to be loaded as a module, then we need to have an alias for this. Dockchannel is a FIFO, but it can have more than one channel in principle, which is why I don't want to just hard code it as a single driver. And that just makes things a bit more complicated than expected. Maybe this should be MFD. I'm not so sure, though. Yeah. I mean, the HID bus will have the HID subdevices. We know that. That's no surprise. But the question is the other layer, right? The FIFO layer. I remember this presentation. I've read this a few times. Uh, Yeah, something like this might actually work. See, the thing is, I'm wondering if this should be done like Mailbox, where there's a device link instead of a child device. Yeah, that might work. So what about this one? How does that one work? Ah. I don't like that. It's not really MFD though. It's what's the closest thing to Dockchannel that we already have? I don't think we have anything. Yeah, the Dockchannel channels have a number for the interrupt. So from that point of view, it does kind of feel like a bus. Mailbox isn't really close, no, because Mailbox uses messages that and Dockchannel is a byte stream. Also, the Mailbox driver and subsystem sucks, and I am not using Mailbox for this. I'm sorry. Like Mailbox is an even worse fit for this than it is for the RTKit stuff we're already using it for. I refuse. But see, this does add the RTC here. But it doesn't make any sense to have Dockchannel stuff like hard code the specific consumers here, because it really is a generic thing. It's not like SMC. I guess this should be called somewhere else though. Like it would be like input at 0, but in this case we have the index, so it might as well be input at 1, and then we just call it like that. And the problem is that then the only problem is that then I don't know if this is really how do we specify the yeah, it could be done by treating the Dockchannel as an interrupt controller, and then it could be done kind of like that. But then this is a bit dodgy, right? I mean, one thing I could do is just list like the whole register range here as one thing, but that's not actually very good because some of these can be locked out, and I'm not sure I want to hard code the idea that the interrupts and the register ranges are always consecutive. I'm not sure if that's always necessarily going to be the case. No, there's the separate FIFOs, but all channels use the same interrupt register set, which is why this can't just be different devices. That's the tricky part. Otherwise, we just use a different dock channel node for everything. But there's a bunch of different interrupt register sets, but there's fewer of those than dock channels, and they all see all the FIFOs. So the idea is that a single agent, like the AP, uses one interrupt register set, which is wired to one AIC interrupt. And then within that might be enabling multiple interrupts for different dock channels and using more than one. And we've never hit that case so far, but it sounds possible. And so I want to design the binding in a way that makes sense for that. Yeah, but the thing is, the reg property indicates the index into the interrupt register the problem is that I don't know if there's always a one-to-one mapping, right? If I mean, I think there is. So maybe that's the way to do it. Maybe we just have like FIFO as a single blob of registers, and then the reg property is it calculates the offset into that of the FIFO registers and the interrupt bit. But I'm not sure if that mapping is always the same. So the main index we need to know is what pair of interrupt bits. I mean, that's the other thing is we could make this an interrupt controller, right? And then we chain another interrupts thing and all that. That's certainly that's certainly possible. Like Dockchannel IRQ as a separate device, and then we just have Dockchannel instances that chain off of that. That would work. But then we still have the client for the Dockchannel, right? What do you mean that's how it's done for GPIO controllers typically? I mean, they are interrupt controllers, but that's because they're interrupt controllers for other things, right? But then the thing is, okay, so we make the Dockchannel a interrupt controller. That's fine. Then what do we do with where does the driver for the actual Dockchannel FIFO live? Like then do we make this do we if we do it if we do this, right? And we could even go further and say interrupts, because there's two of them. So it'd be 0 and 2 and 3 in this case, and I forget which one's which. Where's Dockchannel? TX and RX, yeah. So we can do that. But then if we're doing this should just be, at that point, this should just be an actual syscon. But then we need to make sure that well, actually, no, that does work if we do it like this. Aren't we doing that for the P manager stuff? Yeah, we call it a simple MFD for the P manager, right? So we can do that. But we probably want syscon. Hold on. Okay, Dockchannel is really simple. It's a bunch of FIFOs. They have two ends. That's it. And then there's some global registers which you know nothing about and we're not even using. And then there's a bunch of interrupt registers. All the interrupt registers are symmetric. All of them can see all the interrupts for all the FIFOs. Different things on the bus can talk to one FIFO and use one of the interrupt register sets, and then something else can talk to the other end of the FIFO and use another set, and they talk to each other. The thing is, there can be more FIFOs than interrupt register sets, and only a few interrupt register sets are connected to say ASC. So clearly, the intent is that the CPU uses one interrupt register set to get interrupts for all the FIFOs that it needs to talk to. So, like this is definitely one way to do it. Which makes more sense. But then, how do I probe is the question. Like, do I make this a simple MFD? We need the interrupt to probe first, but that's okay because that will do the defer anyway. No, it gets an interrupt. Like, it gets an AIC interrupt, and then it looks at the interrupt registers in the dock channel. That tells it which FIFOs have data or have space or whatever, because there's two interrupts. So that's why every agent has a set of interrupt registers and can enable interrupts for any arbitrary subset of FIFOs. And see, it's another interrupt. It's a usual like mask flags thing that like every device uses. Also, this isn't interrupt parent, so I want to do that. And then it would just be like this. And then we don't need that. Does that need... Oh, maybe it doesn't need ranges if it's a simple MFD? Yeah, I guess it doesn't need ranges for translate... Oh, no, yeah, we were using a simple syscon there. So that's not quite the right thing. Yeah, because we were using like recmap there or something. So maybe this makes sense. And then we translate from 0 to 2 for AB 0, 0, 0. I think we had how many Dockchannels? It started at 28. It was 4 of them, so that many on this one. Oh, plus 1, 4. Maybe it should start at the right offset, which would be 2, 8. Something like that. But then we're back at okay. So this is now a device that just uses registers. Where do we put the code that deals with the dock channel? I guess at this point, maybe what we should do is, if we would just make this module depend on dock channel, then we can have like the main module still have the code, but then this just calls into that to initialize it. That would kind of make sense. And then it does the actual hit stuff. Maybe we should try this, doing it this way. And then yeah, default bus match table was kind of the trick. But I don't necessarily want to use that in case I need to do something with I remember the simple frame buffer had something about that. It's in here, yeah. Yeah, it does OF platform device create. That will do that. Yeah, maybe we should just use OS platform bus create. I guess it's going to be something like that, right? For each child, do a platform device create P data, so a little bit different from that. Okay, so in Dockchannel, if we're doing it like that, then config and database are going to be in the clients. And we basically move all this here. At which point, I guess the FIFO size should probably move to the downstream device, because it could be different, and it makes more sense there. Okay, config base, database, IRQ base. There's no channel at that point. Yeah, just like that. Okay, so then we have and we can get rid of the syscon and simple MFD stuff. Just let it probe by itself, just in case. Dockchannel, IRQ. Okay, so then we have that. That's basically the only thing we need, and then we need to create an interrupt controller. That was the same way of doing that. GPIO lib might have some of that. Actually, something like that, maybe. Yeah. Was it either a generic IRQ chip or something? Because that might even work. Yeah, this kind of thing. But not ACKP, though. Let's get someone that is actually, yeah. I can use this as a reference. Writing another intro chip driver in the end. Okay. And then we need IRQ mask. IRQ mask. unmask. And this, I don't need an ACK. I think we basically just need those two. Oh, yeah, we do need an ACK. And then I need to remember how these interrupt level things worked and which is the right one. Not that one. This one. Yeah, so it needs to be masked. Where's the core thing for this one? Here, kernel IRQ chip. Mask ACK IRQ. Yeah, so it masks and then that's what I want. Yeah, masks and optional yak. So that's correct. We need the domain ops. So very dumb. Isn't it translate simple or something like that? Yeah, we can just use the one cell thing. Two cell even. Yeah, let's just go with that. Saves a function here. And then let me steal a bit of whatever they're doing for the other stuff, because I bet... Map just as... Okay, I guess we do need map. Oh yeah, because this is the IRQ chip. Do we really need unmap, though? I guess we don't need unmap. Probably don't need unmap. Nah. I don't think we need map unmap, so just map. And then in chip data, we need the Dockchannel common, I guess. Yeah, I just set it to host data, chip and handler, VRQ. Yeah, that's probably fine. And then we can just have mask, ACK. Dockchannel IRQ ACK. We get data that goes into double Dockchannel common. And I can just use relaxed on ACK. For ACK, we do that. For mask, for mask, we do that, and unmask is the same thing but flipped. And then we need the handler. You don't need that. Handler data. Yeah, we just entered the common, and then I don't think they go more than yeah, I did see 32. I saw 28 actually. Is there a for each bit set or something? Yeah, for each set bit. Chained IRQ enter, chained IRQ exit. That's a void. Other things don't even check that. I think we can probably just not care, because that should never happen. I actually don't really need that while loop either. Make it a bit simpler like that. And then we're going to have Dockchannel IRQ, and then we're going to have TX IRQ. These should not be for the IRQ chip anymore, though. So we'll have TX IRQ and RX IRQ. Steal a bit of that. Yeah, these do get the arcs like that. But then this, for the completion, it doesn't. We actually need to mask it and leave it masked. Yeah. So that's for RX, that's for TX, and then we have send and receive. Let's move those up here. And then in dockchannel.h, which is where? Didn't I have that open? Here, include. Oh, I didn't. Didn't I? I didn't create that yet. Then. Um. I think we don't need Apple on this. Okay, so there's some vague API. Weight needs to be up here. might not even need remove if I just make everything devm. And then I don't get driver data because the consumer is going to have whatever for that. FIFO size, we don't need the channel, we do need the completions. Not that, and then we devm request IRQ. Yep, Dockchannel IRQ. No, TX IRQ. So I need it by name in there. Yeah, that. But actually, is there a by name for this? Maybe not. Oh, no, I do need the. There's two different things. Yeah. Wait. Do I want to get the platform device? Yeah. So this is Dockchannel init. It's not static. How does this return platform device by name? Ah. Yeah, it's just the. RX IRQ, and then we request IRQ, DX IRQ. Is that what I called it? Yep. Okay, that should be fine. Mask, ACK. There's the domain ops. Common DCC. And then I need the in. Don't really need a name for that one. Okay, chained handler, and then return 0. And then finally, yeah, before that, then we scan the children. Device node bus ID. Can't it get that itself? Oh yeah, you can pass null for that. It'll make it up. Node bus ID parent. So we just say child, null, and dev. I guess I don't really need to take the return code for that. It should scream if something is wrong, so that probably works. Okay, that should scan the platform devices. And that means this driver should actually work if it compiles. I won't do anything without any consumers, but it should actually like register the bus and the clients. Let's see if let's see how badly I can't find Dockchannel HID. That's not done yet. Right. Let's make dummies for now. Device tree is broken. 794. Semicolons. I always forget the semicolons. What did I break in Magic Mouse? Oh yeah, I need to do the host thing. Bus host group any IDs. Okay, let's see all the brokenness in Dockchannel here. I should probably start using the actual build thing. Oh, I didn't have the Linux thing done here. No, that's not what I want to do. TP mouse, report. Yeah, we don't need that anymore. Okay, disable IRQ. Is that not a thing? Linux interrupt.h. Also, does that request interrupt thing enable it by default? Because raw event spy. Yeah, I guess we don't need that. Oh yeah, this. These are IRQ return T. Oh, because that's the size T, and that's yeah. Actually, is a veil. Yeah, I might as well use size T there. Comma. Shouldn't that be like that? Yeah. Dockchannel no name channel, yes. Wait, why am I even... Oh yeah, this needs to be changed to okay, where are those? Line.h. Unused variable ret. Another min here that we need to, yep. Another min? Oh yeah. And yes, IRQ disable. Yep, no auto n. We definitely need that. Disable IRQ. Enable IRQ. Node. Yep. Chained IRQ, enter. IRQ chip chained IRQ. Find next bit from incompatible pointer type. Really? Argument 1, bit is supposed to be what? Yeah, I guess. I guess it should be unsigned long for those things. Yeah, we need the domain in here. Dockchannel construct domain HWRQ. This would be bit H undeclared host data. The D. But initializer, but incomplete type. That's IRQ domain. I thought so. Dockchannel undeclared. In C domain, it's DCC domain. Ret is not used. Oh, it's building with a warning though. Unused variable Dockchannel. Oh yeah, and remove because there's no remove. But I might need the remove for the IRQ domain thing. Something like that. Is that a thing? Destroy. Is that automatically called? I guess we need the populated bus thing. But we can just call that. DCC domain. Okay, that should work. Let's see if it runs. And I still need to do the HID one, but at least this is a design. I don't know if it's going to be the design we're going to go with, but it's a design for what this should look like. Guest run Linux, not that. Let's try that. Where am I? I think that blew up. Wait, that's... Oh, wait, what? That really didn't work? How did I break Linux so badly that it doesn't even... How did I break it so... Oh. It's stuck in Dockchannel IRQ. Am I not using earlycon? Earlycon should... Oh, wait. I'm running it with trace and stuff. Don't need that. But... Oh, this is a chain load? Oh, yeah, because it's... But yeah, well, why... Why no console? I'm confused. I'm using earlycon. What? How did I break earlycon? What? Just 1 sec. We'll be right back. Yeah, early con debug, no console suspend. No, I don't need to pass console anything, I think. Maybe that's the problem. No. What? We have the chosen... Oh, am I missing stuff here? I needed the standard IO thing. Didn't we have that? Yeah, it's there. Standard outpads serial 0. Am I missing early con? It should be there. I'm really confused. How did I break early con? So how did I end up with that? On Dockchannel... Mask is at 0, flag is at 4. Why am I reading mask? Should be reading flag. Oh, because I typoed this. That would be why. Yeah. Still don't understand why early con doesn't work, though. Yeah, now it boots, but I have to figure that out. Anyway. Morning, I translate to cell. That should work. Okay, that's a thing. And it does have the consumer device, so that's good. I'm using for these chained IRQ handlers when there's a consumers when it shows up. Yeah, still don't know why early con doesn't work though, but was this because of the... You would think no, we did have the serial here. Or maybe I'm just not building earlycon at all. Yeah, it's in there. Oh, unknown variable boot args. Oh, okay. It's not boot args. It's probably the dash. Okay, that explains that. Was it the dash? Probably the dash. Or something else, or command line or whatever. Say boot args earlycon debug. Okay, I think it worked now. Yep. No, unknown variable. What was it called? Mini source. What? Payload. C. What? Didn't we have chosen chain load? This did I break boot args? Or were we just supposed to use the chosen thing? Oh, right. It's like that, isn't it? No. What? What? I don't even remember my own code. Init RD chosen, prepare DT boot. Where didn't we have a boot args thing? Oh, it's just chosen. Right. It became chosen, and then proxy client tools Linux py. It's just chosen boot args. Yeah. Okay, that's supposed to be. Okay. Okay. Now Recon works. Yes. Yeah. So what's that warning about? Translate to cell. Actually, why does it even get called? Because there's no consumer driver yet. Insights less than 1. And that's getting called in what path? Dockchannel platform, yeah, add driver, yeah, for each dev, probe device, platform probe, dockchannel probe. Oh, wait. Okay, I guess the platform device create does actually end up calling translate. Oh, interrupt sales 2, that's the problem. Okay. Yeah, it doesn't show up because I guess it wouldn't until we had that. Okay. Okay. That's that. And now the Dockchannel driver. I should honestly just go to sleep today. Why does everything always take so much longer than you expect? Okay, I'm going to see if I can. I don't think I'm going to get. I think I'm gonna make the keyboard work and call it a day, just to prove that this is not broken. I'll just a proof of concept now, like hard coding the messages or something, and then make the real driver the next time. So why is this GPL? Should it be a GPL and BSD? And there's a lot of stuff was copied. Where's Dockchannel? Not BSD, MIT GPL. Dual MIT GPL channel driver. Okay. Just get some boilerplate done. Well, it's based on that was why, I guess. Yeah. I don't think I'll be really basing anything interesting in here, though, because it's actually a totally different driver, so I'm just using this as a reference. For the... Oh, yeah, and this is the core anyways, so... So first this is going to be a platform device, which means I can just steal that scaffolding from here. And that would be Apple Dockchannel HID transport. Let's go Dockchannel HID, I guess. Okay. So then in Dockchannel, let's get a probe function done. And so here, the probe function would be include Linux. Is it sock? Apple Dockchannel. And let's make a struct. Yeah, if it was significantly based on something, then that's fine. So then we allocate the device. Oh, wait, init. That's not right. I actually include the sock thing. Not PTR error. In this case, error PTR is error. I don't really like the PTR error stuff. Should I just do it with an argument? Not sure. Okay. Also, there's something wrong in the device tree now. Address cells 1, size cells 1. Yeah, that's right. It's address, not addr. Okay, Dockchannel send. Buff. Oh, that's const here. Yep. And then I need to return Dockchannel there. Okay, that builds. That's good. Spy hit Apple Core. So Dockchannel hid probe. Right, so it does the init, and then should this be a threaded interrupt for the avail thing? Probably. Probably steal that from the spy thing. Or was that spy hid OF? What was the one-shot thing? Okay, that's actually useful for us. Yeah, so then we do need one shot for this. Yep, IRQ. Probably works. Oh, it's already on ERX. That one's fine. Pointer from integer. Did I miss something? Oh, IRQ null. Yeah, I need something there. Okay, that works. Dockchannel HID probe. Let me need a kconfig for this. Should probably be moved to like Apple HID or something, but for now, depends on Apple Dockchannel. Depends on Apple Dockchannel and input and OF. I think that's not necessary. Yeah, whatever the module thing. No, don't need that. Yes, and now I need to add that. Yes. Did that actually build? No. Hit Dockchannel. I think the make file is not included right now. Hit Dockchannel, yeah. Transport. Yep, thanks. Okay, there we go. Return 0 there. Okay, so channel. My face. Com. Actually, just say okay, so something for the interfaces. We allocate that HID phase. So we just call that here. Turn null if nothing there. If interface, I think max interfaces. Let's put that in TC HID. Okay. Is that yeah? Thanks. Zero or emit. Okay. Interfaces, max interfaces. If it's there, otherwise it allocates it. Let's call it index. Index name. OF node. I need to get the subnodes. Same thing as I was doing for SMC for that. Drivers. MFD. No, Apple, Mac SMC. Apple? Ah. Oh, it wasn't platform. Platform Apple, Mac SMC, Core. And that was an SMC RT kit. Or just in Core? Or is it just used in the yeah, maybe in RTC Mac SMC. Yeah, that. This is he dev OF node name. I guess we need a device ID here. Are those just ints? Just device ID should be fine. That was called Apple HID device ID. Okay, get the value in there. And then also in the HID Apple Magic Mouse, we need bus host and ID Apple. There wouldn't be any in this case. It would be specifically that multi-touch thing, which I called it 1000. I'll fix that later, but for now, that should be fine. But also for COM, there's no OF node. Um, Okay, so for Pro, we do that when we get interface. DC HID and 0 com. Okay, so we get the com interface. Device ID val. Turn iFace. Okay. And now I need a function for the packet handling. Dockchannel await. DC HID header, I guess. And we define that. Firmware. I guess I need more than one instruction for this. What's that? MTP. That's this one that's not using construct here, I think. Yeah. Is there a pack thing here? That, yeah. So we await the header. That's supposed to be void. And then dockchannel read into that. I'm not sure if this is going to work because it's still kind of recursive, but I'm not sure what would happen. Probably won't work for reads. Yeah. I think I need an actual like work or something here. Um Is there a queue or something like that? Yeah, task lists and work queues, this stuff. Yeah, I think we need an init work or something would probably be a better way of doing this than the threaded handler. Or maybe I just don't need one shot. But if I don't have one shot, if it gets unmasked, well, that doesn't make any sense. How can it get unmasked immediately if? Oh wait, hold on. Right, I need a handler and a thread function. Yeah, okay. But then it might work because then it calls the thread function. It only gets unmasked. Hold on. Oh, maybe I can actually. Maybe I can just say handled for the completions. Yeah, maybe I can just kind of, yeah, I think that actually makes sense. If I, yeah, I think I can probably just return handled when in, yeah, I can probably just do it like that. And then in that case, it's not so much the one shot. Yeah, then RxIRQ and RxIRQ thread. And so RxIRQ will do disable IRQ if awaiting then wake thread. After disabling it. And then here, otherwise, complete it. And just say we handled it immediately. And then we just disable it, which is fine. And then in the thread version, we actually do the avail, set the wait to false, call the callback, and return handled. And so then in HID, this should actually work. Handle packet. Need the cookie. Okay, so now the header is the length channel length sec iface pad. Now for the interfaces, I guess I need txseek, rxseek. We need the interface. Where's the count? And then here, iface, if not iface. Uh, so MTP, read packet. The size is indeed the data, so I guess I might as well read the packet here. It's length. Seed. Oh, hey, Alyssa. Header seek. Dockchannel read header length. I guess is there a generic checksum function in Linux? That'd be nice if we had a simple checksum function. Net checksum h. Can I just use that? There's inline copy. No, it's the first for copies. Oh, see some block add. That might work. It's not CRC. It's a checksum. What? I said checksum. It's not a CRC. It's literally a checksum. Like checksum, literally add all the words. CRC is not a checksum because it's not a sum. People just call it a checksum, but it's not. Um, wonder if there is anything interesting, like maybe not. Oh, yes, that maybe. Have some generic checksum h. Oh, that's specifically for IP. Maybe not. All right. Well, it's only ever going to be used here. No, it's not. We need to send it. Probably doesn't actually need to be unaligned. Oh, but strict aliasing. Oh, the kernel is compiled without strict aliasing. But I guess I should use unaligned. Everything's gonna be aligned though. Let's just do the unaligned thing just to be safe. Yeah, hopefully that doesn't happen. 0 get 9 2 p. And everything needs to add to FFFF, so FDC HID, yeah. Checksum. Checksum, packet buffer, header length +4. Okay, that should do that. Out of sequence, expected. I got better. Okay. So I have to think a little bit about the two channels, so that I don't end up in a weird loop of recursive handling. But that might still work. Might still work with the threaded interrupt thing. But maybe not. Yeah, it might not work. Because the threaded handler is not going to nest. Probably. That's not what I want, yeah. Yeah, so now's when I actually need a Workqueue to handle the packets. Actually, I can probably use the RT-Kit stuff. It had that, I think. Yeah, it has the Qt work, init work, yep. Work, KZA log, yep. And because this is a thread, it doesn't need to be atomic, I think. So yeah, I'm just gonna do it that way, and that way I can have two work queues, one for commands, one for articades. And then I guess I shouldn't really need the packet buffer like this, because I can just allocate it and then copy it. Um, um, and then I can have a void report handler. That's the size. And in this case, just say red code, I guess, and report. That's the size. Yep. So when we get the com one, yep. Struct DC hid packet. Say DC hid work. And then we need the work item thing. We should put this in the iFace. Just say handler. Have a single one of those, but the others are just going to determine the work queue and so let's put that in here. WQ. Not here, sorry. In handle packet. Switch header dot. Yeah, and so I'm going to change that now and actually allocate because I know, so I can still read it into the packet buffer and then just copy it because yeah. Then we can do all these checks before allocating anything. So now and it would be plus dot length that'll complain anyway. Work dot data. Well, she just wrote the data. Not size of header dot length. And then in the work thing, I do an init work. And switch header dot channel. See HID packet work. Now it's always going to be work. Sorry, it's work like that. Queue work. WQ report. No. Okay, get the work queue. The report channel, how do these look? Was I not printing these? This one, yeah, 12. So it's 12 for the reports, 11 for the commands. And I face handler. And then just... Actually, it can just be the work handler at that point. I guess I can just not care with the handler, do that later. So this just picks the Workqueue channel, submits that. And then work. So for the work function, that needs to be... Just takes the work item. Hit packet work struct work. DC hid work. Okay, and now we have to parse the rest of it. I guess it's U8 flags, probably U8 unc. And red code. Okay, now we get the subheader. And then in here, where I was checking those things, we basically have ATR ACKs. So field get flags type into type s header flags. Actually, if s header is greater than, actually size of check work dot Okay, so now we have that. I don't really need the handler stuff here. It can just be a switch in there, and I'm generalizing too much. We can add that if we ever need specific per device handlers, but right now I don't think we do because they're all just hid. I guess I should have the dev here. And then I need the K-free for this stuff. Also, kernel style is like this. And now I need a completion for the commands. And I probably want a mutex for that. Because we could otherwise have commands happening at the same time, which is not a good idea. There are no mutexes in RT-Kit. Yeah, it's just mutex init. So let's just do that here. DC hit. Where is this? And then we complete. Yeah. I think that's reasonable, and we can just say DC hit. Okay, so DC hit diff, we have done. Otherwise, command complete. Red code, DC hid. Okay, command X. Expected DC hit. Command got payload 0. Go to done. If the length is less than 1, another error case. Okay. So then I just write down the red code, complete the completion. That's good. Break. Just say cur command equals -1. Just have it as an int. And in that case, I should initialize that. Okay. Cur command -1. Break. Type command, switch type, need that in here. Case type, report. If it's iFace com, I need the payload for this. The payload is equals work plus the subheader. So if it's com, DC hit handle notification. DC hit report. payload as header length. Default. Okay, just break is fine for these. Okay, packet type. And now the notifications and stuff. Handle notification DC hit. Okay. Okay, let's just print that as like that for now. And then in handle report. And this is approximately the point where I'm just going to bullshit together the dumbest possible implementation. Because I should sleep. So, handle report, we have an interface. So let's see if this builds. So far, it's not going to build. Okay. Dockchannel undeclared. What? Wait, how did I break Dockchannel now? Oh, here. Yeah. Okay. Yes, I need a lot of include files here. I need device. Is that device node? Isn't that in DT? Or is it OF platform or something? Or OF... Oh, it's OF device. What? Oh, struct. Dev undeclared. Relative MK stirred up. I think that needs the yeah, name, and then it needs the GPP. %s, so device name, okay. Ret undeclared, int ret. Dev undeclared, EC HID. Actually, dev of, no, wait. DC HID though. Get unaligned. Yeah, I need the as I'm unaligned on that. Semicolon. DC HID undeclared. Yes. For my %dx, I'm going to type int, and as long as unsigned int. Yeah, I guess I need the LD on those. Oh, that one isn't. Yeah, length is int. Fine. S header. It's just header. .iface, which also needs to happen here. Complete, command complete. Yes. And they also need an init completion in there. Okay, iFace uninitialized. It's work iFace. Dockchannel read. Yes, I need to. No, Oh, rest. Dockchannel. Expected. Work iFace. What? Channel receive. DC. Work. Dot header. Yes. Duplicate case value. And I need to initialize those work queues. Is there a dev end for this? Probably not. What was it? WQ ACK and report. It's not even ACK, it's because those just get completes. Wait. Yeah, I guess I shouldn't really be. I should really just be handing the commands directly instead of using a Workqueue. Okay, I'll refactor this later because it's too late. Report. Okay. Destroy Workqueue, DC HID, Workqueue, ACK. I need to do something about the remove. Later. I just want the keyboard to work at this point. DC HID header undeclared size of channel wait size of DC it is struct. No, it compiles. Okay. Line 310 should display the no, that's correct. It serves the ACK one because that's the one that is initialized. So that is actually correct. Okay. We did get that. We did not get any wait, keyboard initialized? But I haven't sent any inits. Why did that happen? Or maybe that was just something else and there was another one. But I'm not getting anything though. They did even enumerate. Blah, blah, blah. Okay, there's the driver is bound, so that's good. Initialize the waiting packets. And yeah, that's actually trace MTP, but not with the broken. Okay, the syslog worked. And there's no Dockchannel traffic, so clearly that did not work. But it did actually bind though because that was shown as bound. Yeah, it says initialize the waiting packets. Dockchannel await. That should be working. Enables the RX interrupt. Okay, let's do a full trace of the device. Trace MTP. Dockchannel tracer. Set it to verbose 3. Yep, the Linux kernel drivers are a lot more verbose than the mini stuff. That's why we do the Python prototypes first. Streams. Nope, that was not it. Flag writes the mask. Oh, it enabled it and disabled it. Well, that's not good. So I got the message. Are we actually hitting the interrupts? Ah. Call a callback. RX IRQ and then nothing. That doesn't make any sense. How? What? How is that possible that I get that on neither of these? What? And I might like is this disable IRQ going to? Yeah, I think it probably needs to be. I bet it's hung on a spin lock or something. Uh. Yeah, that's why. Yeah, see, it was. There you go. It's that's. Okay, now we're exploding. But it did get the wake thread IRQ. Yep. Callback, and then a null pointer deref, probably because the callback was not set or something. Oh no, it's already in packet work. I think I didn't set something here. Oh yeah, work iFace isn't set, isn't it? About it's got one message received, so that's good. Okay. Another null deref. Somewhere else in packet work. Is iFace DC hit not getting initialized? No, that is getting initialized. Let me address to line that. $162. Oh, the dev? Does DC hit dev not set? No, it is set. Huh? Just print some stuff. No, those are not the what's faulting. Oh, is DC hit not set? Work iFace DC hit? Should be. Oh, yes, because com. Okay, yeah, that's it. Okay, call CB. Got notification, yes. And then I need to await again, because I'm only getting one packet. So after the packet is handled here, and these should probably be go to done. I guess for that one we can just kill it. If that fails, we're kind of screwed anyway. Well, yeah, I should do that. Done. Okay. Okay. So now hopefully we get the multiple notifications. Aha. Yes, now we get multiple notifications. Cool. Let me get rid of the print case. It's very spammy. You gotta give me credit for this. Like, all the checksumming and everything worked on the first try. Like, I just had some missing initialized things, and like all the rest of the logic for parsing packets just worked. So, notification, and this is going to be a I don't have time to do this properly moment. Got notification. Yeah, this stuff. Well, I can try doing it a little bit, not terribly, but let me just get the constants and the structures transferred. Where is that? Device ready message. Yeah. Radius 1. Just got event in it, actually. Uh, Okay, block headers. Yeah, let's just do it properly. I'm not doing GPIOs though, but we can do at least the blocks. Um, so this would be. Oh, did I break that notification event? Oh yeah, I think I broke that. Okay, the handle event. Got event. And I need to get the interface from here. I guess it's handled in it. Data length. And I need to do that, the get interface. So the interface is iFace, yep. Get interface. Return. Get the interface. And now process the blocks. BLK, block header, types of type length. And then switch on the block. Type. HID. Is it block HID descriptor? Init HID descriptor. Init GPIO request. I'm not actually going to implement that, just going to print it. Where am I? init HID descriptor. So let's call this HID init interface iFace data length. And then I just need to bring up the actual HID device. And then handle the reports. So I can probably just steal stuff from Spy here. This needs a struct hit device in here. Yep, hit allocate device. I need to add the country thing, but we'll deal with that later. iFace index. Dev name. Hit fizz as get fizz %s. There's no unique. Hopefully you can just ignore that. Idle driver. Where was my vendor? That's device ID. Yeah, I don't even know if I don't think we need those. Who def parent would be iFace DC hit dev. Driver data is iFace. Yeah, that'll work. Hit device hit. Dev failed to register hit device. iFace name. Return iFace hit is hid. And now how do I get the report descriptor? Request hit descriptors. Hit parse report. Do we need the ready for anything? I guess I'm gonna bool ready, bool open, really. I guess we actually need to store that somewhere. Yeah. Is that a thing? Yeah. Okay, malloc. That's Glenn. Copy there. Then for parse, we just pass that in. I face hit desk, hit desk LAN, and then raw request. Not going to do anything yet. Ignore that. And then output report. Also do nothing. Okay, DC hit output report, and then finally, how do I report something? Process input report. Yep, sounds like this. Init interface, handle init, and then got report. Hit ignore anything when the device isn't open. Actually, we should just be calling those functions the like enable and disable thing. But we'll deal with that later. Actually, I mean, I could do that for the commands because I need to send commands anyway. I was just thinking of doing a really crappy hard-coded thing right now because I need to sleep. Hit input report, data, length. What is 1? Is that the report ID or what? I don't know what that is. Struct HID device. Yeah, I need the HID. FK malloc. Yes. And copy hit disk, hit disk. desklen. If is there iFace HID, return that. Strs copy. Face name HID name. HID undeclared. iFace HID. No, HID is actually just do it like that. HID. And the LL would be this HID LL. Host vendor ID. I need the HID IDs, I guess. Is that not right? Dockchannel HID? It should be under there. Oh, dash. Ret undeclared. Int ret. Return with a value. Yeah, no, return here. Semicolon. Okay. And then I'm just missing the command to enable it. I don't really want to write the whole command handler stuff now, so I'm going to do a real quick hard code thing just to prove that it works. I'll wrap this up next time. Okay. So now I should bring up the devices, but it won't work because we're not actually calling the init function. Not the init function. We're not calling the like start device command. So I'll do that. Okay. Oh, we didn't have a TPXL apparently. Okay. That did not work. Hid device ID property STM activate. Oh, they're all missing hid device ID. That's not good. TPXL is an underscore, right? Oh, iFace OF node. Let's try that again. Ooh, unknown main item tag, magic mouse. Okay, it managed to instantiate that. That's good. Why is generic is yeah. Okay, the descriptor is not working properly, I guess. Oh yeah, no, we got multi-touch on keyboard. That's good. Okay, so I'm just gonna do a real dumb thing right now. Where was oh, I deleted that. Can I undo? Yes. I'm just gonna hard code this for interface 2 in there because I need to sleep. Dockchannel HID. I think this is enough work for today. So in get interface start Yeah, might as well just do it here. iFace index equals to iFace HID channel send DC no, selection only. I got a mouse at least, and I got a keyboard. It says, yes, keyboard interface configuration completed, so that did work. Okay, typing gets reports, but it doesn't actually work. So, oh, am I not passing the reports yet? What report? Oh wait, is it because the console is not? It might be because the console is on serial and not. I'm actually not sure how that works. Okay, so the reports are getting there. That's good. I think it is supposed to print that though. 10 bytes. I think that is correct. Yep, 10 bytes. That's good. Event 3. Oh, it works. Okay, I don't have a test here, but hold on. Can I set the console to not serial? And just you'll have to trust me, but I'll see if like typing on the console works. It does not. Oh, and it still got. Why is it still here? Let's not get early con. I know you can set both, but only one of them is the like input console. Why is that doing that? Anyway, whatever. Yes, I can type. Yes, it works. You're gonna have to trust me on that. Actually, I can just do this. Okay, it's very confused now because of reasons, but hold on. Let me turn off the print got report thing because that's very noisy. Yeah, actually, let me do the setting both. Does that actually work for the actual console, or does it only do it for the kernel messages? Like having more than one output? Ah. No, but it doesn't, yeah. Anyway. Okay, there's some console, like, term issues here. But, I mean, I'm typing. Like, remotely. Yeah, I don't know what the term thing is, but... whatever that is. Oh, it's just because it's, like, printing to the wrong place, I guess, or something. Anyway. It works. I need to get some sleep. The keyboard works. I need to actually implement, sending packets the real way, not this way. And then there's actually not that much left, because after that works, it's basically just a little bit more of like a couple more commands to send and reading the firmware. Like if I do it properly and do the firmware request and put that in memory and send it. But yes, it works. Yeah, you can't hear the normal keyword. Good point. Yes, you can hear this one. You can hear this one. Okay. I need to get some sleep. Thanks for hanging around. And I'll see you next time. Copyright clips. Good night, Joey. Good night, everyone. See you.